Today, we're going to explore Polars, a lightning-fast data frame library for Python. After our video on Pandas, you'll be amazed at just how much more efficient Polars can be, especially with large datasets. Let's take a look and see how Polars can enhance your data workflows. Alright, so think of Pandas as a single lane road where the data flows one car at a time. Polars is more like a whole interstate, a multi-lane highway, and it can handle multiple streams of data simultaneously, making it much faster for large data volumes. Polars is a high-performance data frame library written in Rust. If you don't know what Rust is, that's not important. I'll put a link down in the comments. Unlike Pandas, Polars is designed to handle large datasets efficiently using a multi-threaded approach, which makes it incredibly fast compared to its alternatives. Next, we're going to talk about why choose Polars over Pandas. So why do we choose Polars over Pandas? Well, Polars is built for speed and can take advantage of all the CPU cores on your machine. When working with datasets in the hundreds of millions of records, Polars will generally outpace Pandas by a wide margin. This performance boost is crucial for data engineers working on big data projects or needing faster pipelines. Polars uses efficient memory structures to process the data without using as much memory as Pandas. If you're dealing with limited resources, for example a laptop without very much RAM, Polars will help you to handle those larger datasets without running into the memory errors. Next, we're going to be talking about loading data with Polars. Pandas, Polars can load data from various formats. CSV, Parquet, and JSON data are no problems for Polars. So, you'll see at the very top here, I have commented out the pip install command so that when I post this code clip online on the website, you'll know exactly how to install Polars onto your computer. That was weird. Next, we're importing Polars as PL. PL is normally the alias that we use for Polars. Next, we have this file path. File path is something that you're going to want to adjust on your own machine to make it your own for wherever you're keeping your data files. So here we're creating a DF. DF again stands for DataFrame. Be sure that that's something that you understand. It is common nomenclature. And again, a data frame, for those of you that maybe missed our previous video, is basically just a table of all the records that we're feeding into this data set. So it's your data set from the file that we're reading. So you see that we're reading a CSV. So very understandable, very easy to understand, readable code here. We have PL for our Polars library dot read CSV. And then within parentheses, we have just our file path and then the name of our file. Following that, we're printing out the head. Just like in Pandas, we have the head command that will print out the first 5 records of the data that it reads in. So you could actually adjust this. This is something we didn't cover last time. You could adjust this to 10, 20, 100, whatever you want to look at. I'm going to show you real quick here what it looks like because there's an enhancement with Polars that you don't get with Pandas. I'm super excited about it. This is one of my favorite things about Polars. But real quick, we're also importing the Parquet file. Again, we have PL for our Polars library dot read Parquet. And then again, the file path and name of our file. So very simple, very easy to read. Let's change this to 10 as well, just for giggles so that you can see that it works. And we're going to run this. So this is the cool thing that I wanted to show you. So Polars, when you print out the head, when you print out any of the data frame, you'll actually get, along with your headers, you'll get the data types of each of those headers. So you see that these are strings, these are integers, and as we go down through here, you'll see also that we have our this is our data frame from the Parquet file where we've added the salary with merit increase. If you don't know what this is, be sure to go back and check out our Pandas video that we did earlier in the week. Again, you'll see that I64 for integer, string, F is for float. So really cool. I really like this enhancement with polars that you don't get with Pandas. So, just like in Pandas, you can handle missing values by filling or dropping them. First, let's cover what it looks like to fill them. In addition, I'm going to cover really quickly with you how to filter out some rows. So let's touch on that first. So the filter is your data frame, df, dot filter, and then we're going to say pl.column, .col. And so that is the indicating the column in polars for that data frame, and we're going to explicitly call it by the name of the column that we're wanting to look at. So in this case, we're going to look at age, and we're going to say dot is null. What this is going to return is the null values, the records for the where the age is null in the data set. Next, we're going to take a look at the filling the null with zeros, just like we did last time with Pandas. But this time we're going to do it with polars. So again, df dot fill underscore null, and then in the parentheses, it's so much simpler than it was for Pandas. You're just going to tell it what to fill it with. In this case, we're going to fill it with 0. So any missing values, whether it be in the age or the salary, will be filled with 0. And then we're going to print the head, and this time we're going to change this to 20. I think that there's probably just maybe 10 records in there. And we're going to take a look at that. Let's see what we've got. All right. As I mentioned, we have the original data set because we're printing the head. Because we're printing the head, and then we have the filtered data set with our nulls. And then finally, after the filtered data set with our nulls, we have the new data set with our zeros in it. So we see Jack has an age of 0 and a salary of 0 twice. Because again, just like when we looked at Pandas, same data set. So that's our duplicate. All right, next, we're going to look at what it looks like to drop nulls. So I've commented out the row that is dropping the nulls. We're going to change it to the commenting out the fill null by just clicking and dragging the hashtag up to the column, up to row 12 instead of row 13. And let's take a look really quickly at what it looks like to drop nulls. So we're going to say df again for a data frame, dot drop underscore nulls. Again, a lot of the stuff that you run into in Python, it's going to be very well spelled out. And you'll notice that when you hover over it, this happens in VS Code and other code editors as well. You'll see an explanation of what that function or method does. So again, drop nulls, and then we're going to put this time in square brackets and then in single quotes age. So we're going to look at dropping the nulls anytime that the age is null. So, and then we're going to return that head again. So let's take a look and see what happens. So again, we have our original data set with our nulls. We have our filtered data set for our 2 jacks. And then we have the new data set, which only returns 5 records this time because, again, we have removed our two jacks. So we only have our 5 records. So that is how to drop nulls and how to populate nulls with other values. Next, we're going to look at performance comparison and chunking versus multi-threading. So you might remember that when we went over the Pandas piece, we did chunking. So basically chunking, for those of you that didn't watch the Pandas video yet, you really should go and do that. But for those of you that haven't, chunking is kind of like when you are chopping food for a restaurant. You can only chop so much in your cutting board, right? You're only one person, one cutting board. You only chop so much. You chop that much, you move on to the next. So if you're chopping an onion, you chop an onion or two. You run out of room on your cutting board, wipe it off, put it in the bowl, chop your next onion. So it's kind of like that. You're batching it through. So, however, polars is like having a whole kitchen food full of food preppers. And so instead of having one cutting board, polars takes advantage of all the processors on your CPU and calls up all those processors on your CPU and says, "Hey, I need help cutting all this food." And it pulls all those processors together that it can and runs all the data through it all at once. And so that's what it's doing here. So polars uses a thing called multi-threading. So again, that explanation, that analogy is what multi-threading is, to process the data in parallel. So again, it's like having everybody cutting the food all at once, which eliminates the need for the chunking that we did in Pandas. Unlike Pandas, where chunking is required for massive datasets, polars, again, takes advantage of all the CPU cores to process the entire dataset in parallel, so all at once. When you're adding a new column to polars, it is important to ensure that the new column's length matches the data frame height, which, as long as you're using the column that's in the data frame, then this shouldn't be a problem. But if you're doing some kind of join or aggregation, between potentially two data sets, and maybe one data set is smaller than the other, you could run into issues. So be sure that you're using a field that's in the data set that has the larger number of records. So polars does provide efficient parallel processing, allowing you to handle the large data set smoothly. And let's take a look at what that looks like. So again, we're taking a look at the Parquet file this time because that's our large data set. It does have 1 million records in it. So we're taking the Parquet data frame and we're saying that with columns, we're saying we're going to take our salary field and we're going to multiply it by 2. We have a very generous employer and they're going to double our salary, which is awesome, right? And so we're going to double our salary and we're going to create this new column called new salary. I know it's super creative. And then we're going to print the results. So let's take a look and see what happens. Very cool. Okay, so you'll see here's our new data set. The data set that this printed is actually the CSV. That's not the larger data set, but you see here we have a couple of people named David, their ages, their original salaries, the salary with the merit increase that we added during the Pandas tutorial, and then we have our new salary, which is twice the original salary. So very cool. You'll see that it ran through quickly for 1 million records. It was almost instant. And that is the difference between chunking and being able to do the parallelism that you get with polars. Next, we're going to go through some recommendations and a summary of everything that we learned on this video. All right, so summary and recommendations. We covered what polars is, why it's faster than Pandas, and how to load and manipulate data efficiently with it. Polars shines when dealing with huge data sets. The bigger the data set, the more difference that you're going to see, thanks to multi-threading and low memory usage. So again, multi-threading is, you might hear it also referred to as parallelism. It uses all the CPUs, or as many CPUs as it can gather. It's like calling all your friends over to help with a big project, right? So everybody could do it in parallel all at the same time. So now that you know and have seen how polars can supercharge your data processing, you are now ready to give it a try. I want you to go out there, practice, Find a large data set, go out to Kaggle, go out to data.world, find some large data set to go and practice your new skills on. Let me know in the comments below how you plan to use polars in your next project. And if this video was helpful, be sure to like, subscribe, and stay tuned for more data engineering content. Next time, we're going to put everything together to complete a data pipeline using both Pandas and polars. We're going to compare how each performs and how you can decide which tool is best for different scenarios. Be sure to stay tuned.